So following on from the previous video, let's now try and establish if this sequence will converge or if it will diverge. So the first thing to do is to turn it into a function. So currently it's a sequence. So turn it into a function, and then we're going to differentiate it. And then the first derivative will tell us whether or not it will be monotonic. And then if later on we're going to differentiate it again and look at the second derivative. And then the second derivative will tell us whether or not it will be bounded. Okay, so the first step is to differentiate this. So let's try and differentiate it. Hang on. So to differentiate this, so this is our f of n. Differentiate it. We're going to have to use the quotient rule. But as a reminder, to differentiate this, you should already know this. Differentiate this, it will then give you a constant times itself, 3 to the power of whatever. Okay, so the first step is to differentiate this. So let's use the quotient rule. So quotient rule is you're going to square this. So this thing will be squared, and then this thing stays the same, and then you differentiate this. Remember, when you differentiate this, you're going to get a constant times by itself, and then you have your minus, and then you would differentiate this. That will then give you this, and then leave this alone. So leave that alone, or do whichever method you want. Differentiate this, it will then give you this, and then now it's just a matter of tidying up. If you look at this here, this is exactly the same as this. So you can actually factor it out. That will then give you this. So this will be left in here, and this will be left here. So that would then take us to here, and then here you've got one block. Add this. So if you look at this, you can remove the brackets here. Exactly the same. They will cancel each other out. So it's just going to be left with 1. So this whole thing here is going to be 1. 1 times this whole thing is just going to be this whole thing. So the first derivative is this. Now if you look at this here, so here you've got one block multiplying another block divided by this block squared. So that's what you've got at the moment. But then if you look at this block multiplying with this block here, this block here is always, well, it's a constant. If you look at the natural log graph, natural log of x, this here is 1, 2, 3. This is a constant, and it's always is a constant, and it's above 0. It's always a positive constant. This block here will be a constant, and it's positive. Now 3 to the power of n. So 3 to the power of n looks like this. Well, from 1 all the way to infinity, it's always going to be positive. So this thing's going to be positive. This thing's going to be positive. And then if you look at this thing here, this thing is going to be positive. When you square it, it's going to be positive. If this is positive, this is positive, this is positive, you square it's positive, I'm positive that it's going to be positive. So the whole thing here is going to be positive, meaning that the whole thing here is going to be greater than 1. It's going to be greater or equal to 0. So you know that, well, let's just remove the equal. You know that it's the function or the sequence keeps on climbing. In the case of it being the same, then it's still monotonic. This is still monotonic. This is still monotonic because it's always climbing. Because the first derivative is always greater or equal to 1. In the case of it being greater, it's always climbing, still monotonic. In the case of it being equal to 0, it's a straight line here. It's still monotonic. The point here is that this is monotonic. It's monotonic. So now differentiate it again. So we need to look at the second derivative. So second derivative, quotient rule, square this. It will then give you this, and then leave this the same, and then differentiate this. Don't forget this is a constant. Blah blah blah. Differentiate it, and then blah blah blah. It will then give you. Think about it. It will then give you this. It will then give you this. Okay, yeah, so look at it. So look at it, and then it will then hopefully it will take you to this. And then now if you look at this, here you've got one block. Don't forget this is a constant. Um, and then you've got another block here, multiplying with another block. This block here will always be positive. This block here will always be positive. And then if you look at this block here, let's just look at this thing here, 3 to the power of n. Well, when it's 0, it's already 1. So this thing here, 1 take away 1, is going to be 0. And then the point here is that this thing here is going to be negative. This thing here will be negative. So positive, positive. This thing here will be negative, negative. And this thing here is going to be positive. Cube it will still be positive. But the thing is, because this is negative, this is positive, this is positive, this is negative, positive. Well, the overall thing here, because of this being negative, the overall thing here will be negative. So for all n in the positive realm, f double prime will always be less than or equal to 1, meaning that it's going to concave down. This thing here is going to concave down. So remember, earlier f prime was always positive. Well, we established that it was going to would keep on climbing. This f double prime here, we know that it's going to concave down. But the thing is, what it's actually doing is this. It's always climbing. But the thing is, it's concaving down. It's concaving down. So really, this double prime here is telling us that it wants to do this. It wants to concave down. But then it doesn't actually do this bit here. It only gets it. So it basically it's climbing all the time, but at the same time it wants to concave down. So it's always doing this all the time. So it's always doing this. Hang on. So this is your graph here. So it wants to concave down, and it's also always climbing. So this is what's happening here. It wants to concave down, but the thing is, it's always climbing. So it's doing this. It wants to concave down. In fact, it is concaving down, and at the same time, it's always climbing. It's concaving down and it's climbing at the same time, if that makes sense. So basically, it wants to do this, but then for some reason, it just keeps on going like that. It's concaving down and it's climbing at the same time. So when you get a graph plot and plot it, we don't care about the negative realm. It is actually concaving down, but it's also climbing at the same time. It does make sense if you think about it.